going with the flow. No need to mic you up. Get that.
This makes me feel like Britney Spears, circa like 1999. So. Cool, yeah, so as she was saying, I'm from Algolia. Back there we've got a whole lot of stickers and t-shirts and swag, so please come see us. We're more than happy to throw stuff at you. I'm a solutions engineer, so I help our clients make their search better pretty much. But what I'm here today to talk to you about is something really near and dear to my heart. We all have our passions, and mine is performant web animations, aka getting to 60 frames per second. And my Twitter's there as well, so if you want to send me anything disparaging and you disagree with me, feel free to let me know. Okay, so why should we care at all? Why do we care about performance? It comes down to the user, right? It comes down to providing the best user experience we possibly can. So if our animations or interactions are slow, if they're ill performance, they're going to feel janky, they're going to feel unnatural, they're going to feel awkward, right? Our user who's using our app, they're going to say, hey, this isn't working for me, they're going to toss it aside. Right, slow is the big killer. The skull and bones, we don't want that. But performance is akin to fast. Performance feels natural, it feels silky smooth, it's butter, you know, like when you're putting butter over your toast. That's what performant animations are. Okay, so but what are we actually aiming for here? What is the quantifiable goal? In this case, it's going to be 60 frames per second. So what is a frame rate? It's really just essentially a way of measuring how a site's responsiveness feels. It's nothing more than that. So 60 frames per second is the target for a natural feel. That's the amount that you need to hit for a user to feel like what's going on is natural. It's not laggy, it's not jerky, it's not jarring. What this means, though, if you do the quick calculation there, is that we have only 16.7 milliseconds to achieve all the work and updates that we have to do. And that's not very much time, so we have to be very, very cognizant of the work we're doing and how we're actually doing it. As in all things, there is a caveat. So the more frames, the more processing we're going to have to do. So there are actually some cases where it might make the most sense to aim for 30 frames per second, because otherwise we're going to start seeing frames dropped, and that's actually going to be more jarring and more natural. Okay, so before we dive into the nitty-gritty of this, I wanted to take a quick step back and talk a little bit about what's happening in the browser. So when you're writing code, how is it taking that, what you're writing, and actually putting pixels on the screen? So on initial load, it's going to download and parse the HTML, CSS, JavaScript, all your static assets. It's going to start evaluating the JavaScript, and it's going to start calculating those element styles. That's all great. But where we really start to care is the next part, and this is the layouting step. This is where the geometry of the page gets rendered. So basically what happens is the layout of the page is generated from the render tree. And where elements are placed is correlated to the other elements on the page. And what this means is it's a very highly interdependent structure. If one thing changes, that might cascade and cause another change to occur. And this is also a case, you might have heard of forced synchronous layouts, aka the more colloquial term layout thrashing. And that's what's happening when you're constantly making lots of up-to-date layouts, and that change is cascading and it's forcing other changes to need to be made. So what we can take away from this, and the main gist, is that relayouting, it's going to be expensive. We're going to want to avoid it if possible. So the next step is the actual painting. This is where the pixels of the page are filled in. So the visual styles are being calculated. Something that's important to note is a repaint occurs actually only once per frame. Only what so-called dirty elements are actually redrawn. So the browser actually tries to do you a favor. It starts drawing rectangles around what it sees as dirty elements. So that's elements that have been changed. But the problem is, if you have a bunch of elements you're changing, that rectangle gets bigger and bigger and bigger, and suddenly your entire page is a rectangle. And that's a problem. So, takeaway here, repainting, also expensive. Okay, so you're like, this isn't good yet so far. There is some good news. So the last step is called compositing, and this is where layers are generated. So basically, the default is that each element is painted on just one single memory layer. But what can happen is that elements can be separated onto different compositor layers, which means that any updates that are made to elements on that layer only affect either that element or other elements on that same layer. So the only necessary work that has to happen is to calculate the new position for that particular layer. This is good because what happens is the CPU draws layers, but the GPU actually composite the layers. And the GPU, as you should know, is actually very, very efficient at doing these types of operations. So by separating these layers, we can have non-destructive changes. So if something exists on one particular layer and we need to change it, we can change it, and it isn't going to flow or affect items on different layers. So these are by far the least expensive, and we want to make sure that most of our work is happening on elements that exist on their own composite layer. Okay, so this is all great, but how do I go about actually using this information in a meaningful manner? At a super high level, if you take away anything from this talk, it would be this slide. Only ever change properties that trigger compositing. And those are going to be two things, transform and opacity. And that's it. I know it seems like it can be limiting, but actually there's a lot you can do with just changing those properties. Okay, so for transforms, for example, you can change the position, you can scale it, you can rotate it, you can skew it, you can even do a 3D matrix transformation on it. There's a lot you can do in terms of changing where an element exists on a page, the sizing of it, et cetera, et cetera. So just a quick example here. We have our box, and it's on the left at 10 pixels. And then when it becomes active, what we're going to do is move it 10 pixels over to the left 20 pixels. But instead of doing that, we can choose the more performant option and transform it, translate x 10 pixels to a translate x 20 pixels. This is obviously a contrived example, but this is an example of the type of thinking that's going to make your animations more performant. So poopy face, just in case anybody doesn't realize, that's not what we want. Raised hands. So sometimes, though, you have to get a little bit more creative. In the case of opacity, there's the obvious case of you can trigger the visibility, right? It's essentially display none, display block. However, something to think about is you can actually toggle the visibility level of an element as well. So in this particular case, we have our box, and it has the background color with an RGBA that has the opacity set to 0.9. And so in the top example, we're just doing the transition on the background color's RGBA value. But what we can do is actually set on the particular box this type of behavior using opacity and then trigger the change on the opacity. Again, semi-contrived example, but the type of thinking that maybe sometimes just take a step back and consider how can I do this in a way that's going to be slightly better. Another thing to mention is that opacity is particularly interesting. Any changes you make to opacity, you're going to want to make sure are actually on their own composite layer. The browser isn't going to necessarily do that work for you. You're going to have to trigger it manually. So getting into how you can actually do that. So what can you actually control in terms of telling the browser what you need from it? So good news. You can do manual promotion of elements to their own composite layer. So what this is going to do is say, hey, this element, this item, it needs some help, browser. You basically, by forcing this promotion, you're letting the browser know that it needs to be painted and ready because some changes are going to be occurring, either in the future or just because it needs some help. And actually, I want to drag onto this for a second. So what actually needs help? There's the obvious thing of, yeah, anything that's going to change, anything that's going to be animated or transitioned or what have you. But it's also anything that's paint expensive. So what this means is it might be something that's fixed position, it might be something that has an overflow scroll on it. And I actually wanted to use an example of something that happened last week. I got a Slack message from one of my coworkers, and he was like, so the bar on our dashboard looks kind of weird. I was like, okay, can you define kind of weird? And he was like, well, it's rendering kind of funny, and it's blinking, and it keeps changing position, and you just need to come over here. I was like, okay, what? Because I'm not used to here. I'm used to like, okay, something's kind of funny, but I go over to a screen, and I wish I could have taken a GIF of it, but at the top, the little poopy face, the gradient was wonky, funky is really the only word for it, and occasionally would blink and shimmy just at random intervals. There was like no rhyme, reason, or pattern to it. And the below is what it's actually supposed to look like. And so this was an element that had both a gradient background and was also fixed position. And we were able to fix it by manually promoting it. But this is an example of where an element might need some help that isn't necessarily being animated. You might have also noticed on iOS, especially older devices, if you had a fixed position menu navigation bar, it would sometimes shimmy or flicker. That type of behavior is also an example of where this would be useful. Okay, so but how do you actually manually promote items? So back in the day, which is really about a year ago, we had to use some old hacky methods. Basically, you would trick the browser. So you would either add a backface visibility hidden, or you would do a 3D translation around the XYZ 000 axis. So you weren't actually translating anything, it was just around the 0 point. And this was basically a way of like, hey browser, like come on, like please do some work for me. But it wasn't optimal, right? It wasn't what this was actually meant for. So fortunately, whoever develops the specifications actually listened, and now we have something awesome called will change. And this is basically a method for informing the browser of what types of optimizations are actually going to be needed ahead of time, which is amazing. So you can tell the browser a bunch of different types of things with will change. You can stick with the basic default will change auto, which is just like apply some standard optimizations, not really sure what I need, but like just please give this a little boost. You can tell it that the scroll position is going to change. For example, if you're doing some sort of parallax or some sort of item is moving as you're scrolling, you can let the browser know that. You can let the browser know that the contents will change. You can also actually define to the browser exactly which properties will change as well. And this can be a list. So in my example here, it's will change transform and also opacity. Also worth noting, so this is actually supported now in Chrome, Firefox, Safari, and Opera. You might have noticed IE is missing from that list, but we'll see, one day. One thing I also did want to mention was, as in all things, moderation. So the browser is already trying to do its best for you. It's already trying to optimize. And these stronger will chain optimizations, they're pretty resource heavy. So you don't want to go crazy and like do like an asterisk and then will change auto on every single element, because you're actually just going to get yourself into a deeper hole. One thing to mention is if you're animating these non-GPU properties, the browser might actually be forced to repaint it on the CPU and then re-upload it to the GPU, which can actually be more costly. So by using will change, you're basically saying, hey, at any moment, this item could be changing. So keep that in mind. This is a heavy stick. Heavy is the burden on your shoulders with this one. So just something to keep in the back of your head. Okay, so how do you go about actually accomplishing your goal of producing animations? There's two sides to this coin, imperative as well as declarative. So CSS being declarative and JavaScript being imperative. Declarative animations using CSS, generally, off the bat, this is going to be more performance. Generally is in there because obviously there's always going to be some caveat, there's always going to be some situation. But the main idea here is that the browser knows the endpoint, right? It knows the full extent of the animation, so it can actually optimize for that. Also, it's being run off the main thread. So a lot of work can be done on the main thread while the animation is happening aside. One thing to mention is obviously it's missing the expressive power of JavaScript, right? You can't necessarily respond to user input in the same way that you can with JavaScript. That is the one caveat. When it comes to actually using JavaScript, as mentioned, it's going to run on the main thread, which is much more likely to result in dropped threads. However, you do have more control. You can respond to user input. You can stop things more easily. I have a quick example here where the idea of what you can do is just toggle a class name, right? So if you know you need a certain amount of work based off a user, say, clicking a button or toggling a button, what you can do is basically just use JavaScript to listen for that event and then toggle a class that does the rest of the work for you. Okay, but what if I really, really, really need JavaScript, you say? Like I promise, like I swear I really need it. So there's this thing called requestAnimationFrame. I'm sure plenty of you actually probably already heard about it. But basically, it's a set timeout of the 21st century. It's a native API for running an animation. So it's typically going to be called at around 60 frames per second. Again, caveats all around. But the idea is it basically requests an animation drawing at the next available opportunity. So not at any particular set interval when it recognizes it's going to make the most sense. And the browser can then optimize performance and group things into a single repaint, which is going to save on those CPU cycles. And the cool thing is actually this has IE10 plus support. So all around you can use it very, very safely. I have a couple quick code examples here. You can call it recursively. So in the case of my do something function where I do some stuff, I can call it via requestAnimationFrame, do something. I also have an example here of adding it onto a scroll event, which is a really, really good use case for requestAnimationFrame. And I just call it on, in this particular function, is going to be toggling a collapsed class, wow, that's difficult to say out loud, for like, a header as you're scrolling down, the header collapses. Another thing to mention, something I mentioned earlier, is the idea of forced synchronous layouts. So again, that sort of layout thrashing. The idea is you want to read and then write, because the browser is going to keep tracking those dirty elements and then queuing up those changes until necessary. If you're reading those properties prematurely, it's going to force a premature calculation. It's going to cause reflows, right? You're going to want to group your work in terms of when you need to actually do it. So again, just a really quick code example. This one is super contrived, but you've got some boxes, and for each box, you're doing a few changes on the width of the box. But inside the for each of the first one, you're doing some additional reading of the DOM. But in the second example, just pull that out. You don't necessarily need to do that work inside of that for each loop. OK, so this is all great, but we can go even further. There's this awesome new thing that actually just got support in Chrome and Opera super recently. It's called CSS containment. And what it lets you do is indicate that an element subtree is actually separate from the rest of the page. So this lets a browser know that it's safe to optimize an element. So there's a few things you can indicate here. You can set contain to be strict, and this is going to set all rules. You can set contain to be contents, which is all rules but style, size, layout, style, paint. There's a lot of different things you can indicate here, but it's a good way of segmenting a particular element or grouping of elements away from the page. So this ensures that any DOM trees, DOM updates that are happening in that subtree aren't flowing up or affecting anything else above it. Actually, one of the most interesting ones here is contain style. This actually contains the styles of that subtree to that particular subtree. So in the case of, for example, if you have like a third-party widget or advertisement, you can set these type of containment properties on it to ensure that whatever code was packaged in that strange bundle you received and marketing was like, put the script at the bottom. You can help ensure that that's not going to flow and cause damage in other parts of your site. Another final note I want to mention was sometimes you just have to get a little bit hacky. You can follow all these best practices and things just still are not going to be going right for you. One example I wanted to share was a few months ago. I had a client and we were working on something. It was actually a seat map. You're going to go to Ticketmaster and you're trying to purchase a seat and lots of seats appear. So we did something that we thought was really cool at the time where we changed that to be from a canvas object to be an actual SVG with lots of paths. But then we realized that the client we were testing on only had 100 seats, but then we had a client who had 2,000 seats. And it turns out that when you have 2,000 paths that all have event listeners on them, and you try to do a transformation on that on a mobile touch device, everything goes to hell. And even though we'd applied all these optimizations and we'd done a lot of thinking about it, it still wasn't right. So we ended up doing something super, super hacky, where when a user on a touch device started pressing on it and started trying to move the SVG around, it actually got rid of the SVG and replaced it with an image. And you actually couldn't really tell, to be honest. Like, this isn't the greatest thing in the world. I admit this. This is not like perfect. Like that commit, I was not like, yes, go Emily. Like, I'm so proud this is out in the world, my name on it. But it worked, And sometimes you have to think a little bit outside the box. One other thing I also quickly want to mention is, so how do you go about actually testing this stuff? So obviously you can eyeball it. That'll work pretty well. But again, if you're on the case where you're on your MacBook, that has a million whatever gadgets and wizards and you're on Chrome, that isn't necessarily emulating the experience of somebody who's on, 3G on their iPhone 4 and I don't know, whatever strange browser they have. So the point is, you have to get a little bit deeper. One particular thing I think is really, really useful is this rendering bit. So they really hide this from you, but on Chrome Tools, if you hit the three dots and you go to More Tools and you go to Rendering, there's all these really funky, awesome options. You can check off paint flashing. And what this is going to do is going to highlight areas of the page that are being repainted. It'll be a big green rectangle if everything's going okay. But then it'll start being a lot of red rectangles, and that's when you know, like there's a problem here. Layer borders, pretty similar. Will show you actually where the composite layer borders are. If you have z-indexing issues, this is also a handy one as well. Frames per second meter will actually show you what your frames per second are at any given point and draw a little graph for you. And scrolling performance issues is something that is amazing, and again, we'll basically just draw a big red rectangle. I mean, the main takeaway here is green good, red bad. There's also this amazing thing called timeline that has really, really started to grow in the past. Like, I feel like every single time I check it, they've added something new, which is awesome, but it's also gotten way more confusing. But the basic idea here is similar. Green is good, red is bad at the top here. But the cool thing is when you see this red, you can actually drill down into that particular point, and you can drill down and you can actually see what function calls are causing all the fuss. And you can say, hey, okay, where I'm doing this, like read the right, where I'm doing this, whatever, this is what's the point where I need to actually revisit this. So this is really going to tell you everything you could possibly know, and probably more. So yeah, that's pretty much all I had. Thanks so much.
Thank you.